So again, we're going to do a pretty good review of this storm, which affected us earlier in the month. Not too much in the way of snow, but you can see there's a snowman there. That's at Polar Park in Worcester. And on the bottom left is a school bus moving through some floodwaters. That's from coastal flooding out on Martha's Vineyard. So this storm kind of featured a little bit of everything. As usual for us, it was a challenge to forecast, but as I'll show you, the models actually did a pretty reasonable job, even several days in advance. So let's go ahead and start with the overview. So again, this late season nor'easter brought us rain, snow, coastal flooding, and strong winds, like many of the storms that we see during the winter and early spring. We did see another round of river flooding, though, in Rhode Island and eastern Massachusetts from already swollen rivers. Throughout the winter and spring, those areas really got hit hard with a number of flooding events, especially around Providence and into southeast Massachusetts. And this, again, not a lot of rain, but enough to kind of bring another round of some minor flooding. The real forecast challenge was the snow and sleet. Really, looking at yet another storm with kind of marginal temperatures hovering around freezing. Usually that favors some of the higher elevations, and that was certainly the case here once again. Although even some of the areas along the coast did see a little bit of snow for some time. And we had a period of high astronomical tides, and that combined with some strong east to northeast winds produced minor to moderate flooding, tidal flooding, coastal flooding in eastern Massachusetts. And overall, as I mentioned, the forecast models did provide pretty accurate and consistent guidance. So it really allowed, for a heads up several days ahead of time. And we're going to focus tonight on forecasting some of the different aspects of the storm and go through some of the general rules that we like to follow. So just to kind of refresh everyone's memory, it's been a few weeks, but this was a storm that really brought the heaviest rain into parts of Connecticut, Rhode Island, southeast Massachusetts. You can see in the areas where there's yellow shading, that's over about 1.5 inches of rain or so. So it was really confined, to the southern areas this time. But even, some of the areas out in northwest Massachusetts saw upwards of 1 inch of liquid precipitation. That was in the form of rain or melted snow. And in this case, Cape Cod and the islands did fairly well. That was something over the winter. They really missed out on a lot of the heavier rain events. And for a time, Nantucket was even in some drought conditions, but that's since been alleviated. And this certainly was a much needed rainfall for the Cape and the islands. The snowfall, on the other hand, I think I can probably show you every winter storm map from this past winter, and it looked like this, really highlighting those higher elevations out toward the Berkshires in particular, northern Worcester County, those higher terrain areas, maybe about 800 feet, and really not much else elsewhere in the lower elevations, 1 inch to maybe 2 or 3 inches in some spots. But overall, this was really a storm for northern New England. Once you went across the Massachusetts border, over 1 foot of snow into central and northern New England, and once again, the ski areas did very well. The wind gusts, again, confined to the coastal areas, 40, 50 miles per hour plus, and even higher than that around Boston and even Cape Cod and Nantucket. The image isn't really true to form, though. It really is based on observed data, and the lack of observations out here in western New England kind of, make the image a little bit less than reliable, but still gusts around 40 miles per hour through the Connecticut River Valley as well. So strong winds across much of the area, but really focused along the coast and especially the outer Cape and Nantucket. So the main impact from this storm were power outages, and really the areas that got hard hit, New Hampshire and Maine, where they had heavy wet snow along with some strong winds. That's where, more than 100,000 customers were without power. Here in southern New England, still a fair amount in Massachusetts and to a lesser extent into Connecticut and Rhode Island. But, overall, this was really the main impact from this storm. In Massachusetts, it was interesting because if you look at the map of outages from the Massachusetts Emergency Management Agency, you'll notice they're kind of focused in a couple of areas. Now, we do have some sporadic outages in northeast Massachusetts where there were strong winds, but really the western part of Worcester County and even the slopes of the Berkshires, and these were areas where, since winds were out of the east, they would go up and over the hills and then actually rush downward. That's called downsloping. So in this case, some of the western sides of the slopes actually had stronger winds than the east side, which you wouldn't normally expect. But here was roughly, the peak over 31,000 without power in Massachusetts, and that was as of the morning of April 4th, and it was restored fairly quickly after that. All right, so we'll get into some of the weather here, and this is a loop of our 500 millibar charts, about 18,000 feet. And as you remember, this is where we look at essentially for our steering of weather systems. And you'll see as the animation starts again, we've got a trough, a southern stream trough moving from Texas, kind of links up with this northern stream trough in the northern plains, and you get this big closed low that kind of slowly migrates across the Ohio Valley and eventually New England. You'll see it again. These two troughs kind of phase with each other, as we call it, and form into that closed low. And it's this energy on its eastern side that provides lift that helps the nor'easter form to the east of the Appalachian Mountains. Now at the surface, you'll see the loop here as well, showing our primary low over the Great Lakes and our secondary low developing east of the Appalachians over the mid-Atlantic coast and eventually heading right up into southern New England and taking more of a track right close to the south coast. This is known as the Miller Type B storms, the ones that reform somewhere off the east of the Appalachians, usually near the mid-Atlantic or Carolinas, where our Miller A storms are the ones that form in the Gulf of Mexico. And we saw a lot of those this winter. Those are the ones that tend to be very warm and moisture-laden and can bring a lot of rain and strong winds. So that was really the dominant type for the winter. The Miller B here was kind of an exception for most of the season. All right, so we're going to take a look at forecasting this kind of from the big picture down to the kind of the finer details. That's what we like to do in our forecast process. So several days out, we start to look at things like the situational awareness tables that show us different parameters and kind of what are these values relative to kind of normal or relative to climatology. And you'll notice in the red boxes here, we've kind of highlighted a few areas. First of all, and they're all kind of centered around April 3rd, April 4th, which is the time frame of when the storm occurred. But if you look at things like the 500 millibar height, which is the Z, they're at relative lows, which makes sense when you've got a big closed low moving over you. Looking at some of the wind components, in particular, the U component is the east-west, V is north-south. So this is telling us we have a very strong southerly flow in place, and along with the wind speed. And then when we look at some of the moisture variables here on the right, this is our precipitable water, which pretty much tells you how much moisture is kind of available to wring out. And a lot of those are getting near their maximums as well. So you're looking at a system that's going to bring a lot of wind, probably a lot of warm temperatures as well. We've got some higher percentiles of temperature and a lot of moisture. So it's just not telling you exactly what's going to happen, but kind of telling you what could happen, what we're in the ballpark for this particular storm. Then we can look at another of these anomalies that we look at. And again, these are relative to climatology. And when the numbers get a lot higher and go negative, so -4, -5, and a lot of this purple shading, this is a signal for a potentially big event. And in this case, signal for potentially strong and damaging winds across most of the region. And in addition, these easterly winds, which we're seeing from the wind barbs, they also favor the strongest winds along the coast. And on the, as we said, the west side of the Worcester Hills and the Berkshires, where you have that downsloping. But again, kind of gets you in the ballpark of saying, hey, something, a pretty big storm system could be impacting us during this time frame. Now, something else we look at are the analogs that come from St. Louis University. I think we've shown some of these in our reviews before. And all it does is it takes essentially the latest GFS forecast or the latest NAM forecast, and assuming that forecast is perfect at a certain time, we'll go back in its database and find similar situations. So it kind of gives us a clue as to what can happen. And you'll see, in this case, the leading analog was a storm on March 1st of 2005. And it doesn't just look at the surface, it looks all through the atmosphere. So as I showed the 500 millibar pattern, maybe a little bit lower at 850 millibars, things like that. So you'll see the main takeaway here, look at all these postage stamps that have some sort of coastal low right off the New England coast. You'll see just about every one of them does. I'm going down through 6 and even 7 to a lesser degree, 8, 9, and 10, and all the way up through 15. They all have something there. So there's a pretty high likelihood that there'll be some sort of coastal storm when compared to these analogs. And we can also look at some of the other guidance from these analogs. For example, here's the liquid precipitation. And you'll see a number of these have heavy amounts. So we're getting in the blues, we're getting over an inch, and the purples over 2 inches. And notice the top row of analogs. A lot of them have some heavy precipitation, 1 to 2 inches plus, especially this March 30th, 1984 analog. Very few have light amounts or nothing at all, maybe just 1 or 2 in there. So again, it's telling you the odds are kind of favoring that this is going to be a moisture-laden system with a lot of precipitation coming through. And we can also correlate that to snowfall to a lesser degree, but it does show some what we, I would say some big hits, as we like to say, when you've got the pinks and purples in there. Those are over a foot of snow, and it's not going to tell you exactly where the snow will be, but it will tell you somewhere in the region there's that potential. Again, we've got 3 analogs in the top that have some decent snowfalls in there, and a number that have at least some accumulating snow. So it's telling you, all things being equal, there's the potential for some big snows somewhere in the Northeast. And we have to look at some of the other model data to diagnose that a little bit further. Okay, so let's go and forecast the storm now into the GFS time range, and kind of a quick loop, but it kind of shows the evolution in the days leading up to the storm, which actually remained fairly consistent from run to run. It's showing what we call a more inland track, not true inland track across the Great Lakes, but one that's along the south coast, and that really favors the heaviest snow, first across the higher terrain for us here in southern New England, but really more across central and northern New England. Again, thinking those ski areas tend to be more favored with a low track right along the south coast, and tends to be rain really for the rest of us. So, as a big picture, you'd say, okay, odds are favoring, a track near the south coast. This doesn't look like it's going to be a big snowmaker for southern New England, maybe outside of the higher terrain. So again, the global models, they were rather accurate here. And this is a snow depth map from the GFS. And we like to use those when temperatures are marginal. We'll talk a little bit more about that in a minute. Because the usual 10-to-1 snow maps you find online can be really misleading and overdone. In this situation, the snow to liquid ratio is not 10-to-1. It's maybe more like 5 or 6-to-1. So those amounts are going to be overinflated. But this really takes into account surface temperature and the accumulation of snow. So it does a much, much better job. And you can see, at least qualitatively, the GFS didn't do a bad job here when compared with the observed snowfall here on the lower left. Northeast Massachusetts, pretty sharp gradient, and that was actually our area of greatest uncertainty. We didn't know really if enough cold air was going to drain southward to force more of a change to snow there, but really shows those higher terrain areas very nicely here in southern New England. Now, getting into the closer window of the storm, we go to the higher resolution models. This is the NAM 3-kilometer version, which I'm sure many of you are familiar with. And again, the snowfall forecast still very tricky, especially in northeast Massachusetts, due to the marginal temperatures. So, questions about precipitation type or the snow ratios, as I just mentioned. And one of the rules of thumb that we use when we see like a potential for heavy sleet, which is indicated kind of by the red here that's shown, or purple, is use like a higher temperature as a cutoff for your accumulating snow, because the models don't accumulate sleet very well. It's going to be underdone. So we allow in our forecasts a little bit more to accumulate by raising that temperature. Typically what we use when we do our snowfall forecast graphically is about 34 degrees. But that would be too low and would give too much accumulation. So we raise it up, and that knocks the accumulations down a little bit and gives something that's a little bit more realistic. And we'll talk about sleet a little bit more, but that's certainly always a challenge. And an inch of sleet can really cause a lot of problems, a lot of impacts, especially with travel. So another thing that we look at, this is going up a little bit higher to about 5,000 feet or about 850 millibars. And we look for the low track at this level because it really helps us with a couple of things. One is with precipitation type. Another can be with the potential of a dry slot moving in, and then with some of the banding, which you're seeing in this red and purple shading. That's some of the banding occurring. But again, as we saw with the surface low, notice where the track is. It's up along southern Connecticut, Rhode Island, southeast Massachusetts. That's a warm storm for us. You're not going to get big, heavy snows with that. Again, it's going to be focused more across central New England, northern New England at this point, meaning rain for much of the area. Again, those higher elevations, depending on temperature, can benefit quite a bit. But often, this is more of a warm storm for us. And if the low track's even further inland, then we talk about that dry slot I was mentioning, which is kind of on the east side of the low. We get some drier air wrapping around it, and it essentially shuts off any chances of seeing any heavy snow. All right, so we talked about sleet, and we're going to get into a little bit more of that by using some of these forecast soundings. And this is what we really relied upon heavily in this case for the storm. This sounding here is a classic sleet sounding, and it has a few different things. So first of all, I'll just point out what we're looking at. The red line, which you can see, is the temperature. And now we're going up in the atmosphere, so the surface is down here. And then we're gradually going up and higher to different levels. So as we're seeing, temperature is in red, green is dew point. So when they're close together, it's a saturated or highly moist atmosphere together. When we're looking at temperature, this is the 0 line. The freezing line I've highlighted in white. So anything to the left of that is below freezing. Anything to the right is above freezing. And what you'll notice are two different distinct layers. Near the ground, you've got a pretty deep layer that's below freezing. And above it, you've actually got a layer that's much above freezing. So it's warmer. And think about it as a snowflake will kind of descend through the atmosphere. It's going to start up here. It's going to descend into this warm layer, and it's warm enough, it's going to melt into a raindrop at that point. There's plenty of warm air. It's certainly warm enough. It's 6 Celsius, which is very warm. But then as it descends, it's going to hit this cold layer that's above the ground. Then, depending on how deep it is, it's not too deep here, but if it's deep enough, it can change back to snow. But if it's not, it's only going to partially refreeze. And that's when we see sleet, or what's called ice pellets. So this is a very classic sounding for sleet. The warm layer aloft, followed by this layer below freezing, kind of just above the ground. So when we see this, we know that really sleet is favored. And this was a sounding taken from near Worcester that really showed that potential very, very well. Now, if we compare it kind of with all 3 different precipitation types, I'll show you, there's a good example here. Again, we're using that white line as the freezing level. The green is kind of the red is your temperature. So let's look at that. To the north in Concord, New Hampshire, notice how the entire sounding is to the left of this line. So this entire sounding is moist. It's below freezing. That's going to favor all snow. Going to the Worcester sounding again, notice we've got this warm layer to the right of the white line aloft. We've got a deep cold layer below that, so that's going to form sleet. Again, the rain snowflakes will fall and melt into rain and partially refreeze into sleet. And then to the right at Providence, notice a majority of the sounding is near or above freezing, especially aloft. This is a very deep, warm layer, which is tough to overcome. It's not quite cold enough below. So this is going to favor rain in this case. So that's kind of what we use to diagnose, kind of imagining what a particle would do as it comes down, transitioning from snow to either sleet or maybe to rain entirely as it melts going down. But that's how we look and use these soundings to kind of diagnose what type of precipitation we can expect. So we can also look at some probabilities, and I'm sure you've seen some of these on social media, and this is just exceeding specific amounts based upon ensemble guidance, which again is one model run a number of times with different conditions. So we're looking at probabilities at a given time, and these can change also. But notice ahead of time, we're showing the chance of 3 inches or more of snow in about 48 hours, ending that Friday, really focused across the higher terrain of the Berkshires, northern Worcester County, and areas to the north. Likewise, we're seeing probabilities of 6 inches or more of snow in kind of those same areas, and virtually nothing outside of that, down to about zeros in many of the coastal areas and the lower elevations. So this gives you a big signal that this is going to be kind of one of those high terrain events that we really saw all winter long. Now, if we go into some of the high-res ensembles, this is the HREF, which is the high-resolution ensemble forecast using a collection of high-resolution models, like that 3-kilometer NAM, but it's showing the accumulated snow, kind of the same picture. Again, highest amounts across the Berkshires, maybe the east slopes, and more across northern Worcester County, and especially over the border into New Hampshire and Vermont, with little, if anything, farther to the south across the coastal areas and in the lower elevations, the river valleys. So again, using this with some of those earlier ensemble probabilities gives us higher confidence that really this is going to be kind of a higher elevation snow event. And indeed, here's a look at our snowfall forecast. On the left was kind of the first shot that we had on April 1st. On the right was kind of the last call on April 3rd. And you could see very little difference in between the two, maybe a little bit less snow across part of the Berkshires and northern Worcester County, but really the same overall signal. That's where the heaviest snow was going to be, and little, if anything, kind of outside of that. And our forecast, here's the last forecast here on the left compared with the observed on the right. Overall, a pretty good forecast, went according to plan. Again, this area of Northeast Mass was the highest kind of uncertainty where we had some temperature issues essentially. But overall, a pretty good forecast, and the higher amounts were just over the border into New Hampshire instead of Massachusetts. All right, so let's move on now to assessing the high wind. And not as quite as much to look at here, but a couple of signals that we saw. This was looking at the high-res ensemble. First of all, this is at 850 millibars, 5,000 feet, and shows a pretty healthy easterly low-level jet here. You can see by the yellow, orange, and even red and pink colors, all very strong winds coming out of the east. A long fetch over the water, which helps to modify the air mass, makes it a little bit cooler as you go up, which helps transport a lot of these strong winds down. It's called mixing. But certainly you can see, a lot of wind coming in. This also has a lot of moisture with it. So it's going to help add to the moisture that was already being transported from the south. Again, we use soundings to assess the wind gust potential. This is a look at a sounding from the GFS over Boston. And again, we're looking at the red curve for temperature, the green for dew point. So you can see fairly moist all the way up several thousand feet. Notice all the very, very strong winds in here. In excess, these are in knots. So over 64 knots, which is a hurricane force gust at that point, 70 knots. So really just right off the ground, the winds were very, very strong. Now, one thing that we have in BuffKit, which is really nice, is it will show you the actual height of the potential mixing based on temperature and the values associated with it. So in this case, we're looking at a lower bound of 42 knots, which is kind of the average through this mixed layer. So at the very least, you can kind of expect about 42 knots or 47 or 48 mile per hour gusts. But notice it also gives you the maximum in the layer, which in this case was 54 knots, which is about 62 miles per hour. So actually, this wasn't too far from reality. We had a gust of 59 miles per hour reported at Logan during the storm. So this really helps get you in the ballpark. And what we notice is sometimes if the temperature is just a little bit warmer than what the model shows, it's going to mix a little bit deeper. So if I put my cursor here and mix, you're going to mix a little bit higher, and you'll be touching those higher wind values. So, but overall, did a very, very good job in this case. So here's the forecast of our maximum wind gusts, and you can see highest gusts along the immediate coast and across the higher elevations as well, where there was a little bit better mixing, especially out toward the Berkshires. And this is kind of a timeline of the winds, looking at various locations here in southern New England. And we messaged essentially the potential for power outages, especially where the wet snow could accumulate on some of the trees on the power lines. And how to verify, not too bad. A little bit underdone, I think. We had definitely some stronger gusts around the Cape and Nantucket and even into Boston. A little bit low here as well, as you can see. And the analysis, as I mentioned, was probably a little bit too low out here. I believe they had gusts in the 40s and 50s out in that area. So overall, from an impact standpoint, again, pretty well forecast for the wind potential. Okay, we'll move on now to the precipitation, essentially the rainfall. And again, starting out with the ensemble data is really, really useful because it helps us iron out that uncertainty that we might see in the models from run to run. They might shift the axis of heavy rain, and I'm sure you've seen that with rain and with snow. So on the top left, we have some values, the mean from the GFS ensemble. On the right, top right is from the Euro ensemble. Lower left is the Canadian ensemble, and then all three combined together in the lower right. And you can see, they're all in the ballpark for a 1 to 2 inch rainfall, mostly focused eastern Massachusetts and Rhode Island. You can see the Canadian was a little bit higher than the rest of the guidance, but not too much higher, but definitely showing the potential for at least 1 to 2 inches of rain during that 24-hour period. Again, seeing similar values, similar locations gives us higher confidence that those areas will be impacted. So going in now, we're into the high-res window as we get a little bit closer. You start to see a few more details worked out that some of those coarser global models can't really handle, but kind of in the same picture. Again, you're seeing heaviest rainfall Rhode Island and eastern Massachusetts, although a little bit less so here in Rhode Island. It's got a little bit more on the Cape. And a secondary max associated really with the snowfall across northern Worcester County near the Berkshires and essentially Essex County up into New Hampshire as well. So it's getting into more of those banding signatures that we see in the models. There's always errors in placement with those, but kind of giving the signal that, these areas are certainly a little bit more favored for heavy rainfall. And of course, the rainfall led to some additional river flooding, and this is some of the messaging that we had used showing renewed rises on the area rivers, highlighting in with the orange squares some of the ones that were more vulnerable to flooding, as well as some of the coastal flooding areas as well. And again, here's a look at the observed rainfall. You can see we were a little bit too far to the west with our axis. Definitely more rain fell across, say, the Upper Cape, Martha's Vineyard, and even the Outer Cape. We were a little bit too low there. That was along with that model bias that we just looked at, and a little bit overdone across parts of the interior. So things shifted a little bit to the east from what we expected. Some of the impacts here quickly. In Rhode Island, the Patuxent, the Wood Rivers again were in flood actually several times over the winter. This fortunately was less impactful, just remaining into minor flood as opposed to moderate or major. The Pawcatuck as well at Wood River Junction and at Westerly went into minor flood, as did the Taunton River in Bridgewater was in flood for several days as a very slow responding river. And the Charles River in Dover, same situation, very slow responding, slow to rise and slow to recede. So those were in flood for several days. And finally, we'll take a look at some of the coastal flooding here as well. Again, this has become more of an issue lately with all those storms we had over the winter with coastal erosion, a lot of inundation along both the east and the south coast. So in this case, we had concern for essentially minor flooding, but there's always uncertainty. This is always difficult to tell because you want the surge to line up with the time of high tide, really, to see the most significant flooding, and that doesn't always happen. So what we've started to do is message these to our emergency managers by using some probabilistic hydrographs. And you can see the most likely forecast, this would be for Boston, is on the black curve. And then what could happen is kind of in the shading in between. So there's a pretty good range here, anywhere from about 11.5 feet on the bottom to up to its moderate flood of nearly 14 feet on the top. And while that uncertainty, well, it has to do a lot with the timing of the surge, but also with the strength and duration of the strongest winds as well, and the direction of the wind. So any of those things change, you're not going to get to this maximum surge or maximum height. And you can see also on the left, this is Providence, and much, much more of a difference here. That's due to differences along the south coast, which, what was the wind direction going to be? If that low that was along the south coast went farther inland, say to Worcester, then we would have been dealing with southerly winds where the south coast would have been more impacted than the east coast. So this is just really a good way for us to communicate with emergency managers and show them kind of the potential range of outcomes. Because coastal flooding is just, again, we really sometimes almost don't know confidently until almost 3 to 6 hours ahead of the storm when that surge is actually occurring. So what kind of did happen? Well, the surge guidance was pretty darn good. On the left is from our Stevens Institute guidance, and you can see, again, it shows you the most likely forecast in red, but with that gray shading that tells us our range. And notice it verified kind of near the lower end of it, maybe lower to middle, with a surge of about 4 feet, and that was actually predicted very well by the models. What's on the right is what we call our PETS guidance. That's the probabilistic extratropical storm surge model. So there is a model that we use day in and day out called the extratropical storm surge model, and that does storm surge for our typical nor'easters. But we have a probabilistic version, which gives us, again, that range. You can kind of see that in the gray and gives us a worst case scenario. So in this case for Boston, the astronomical tide was rather high, 9.3 feet, but you had that 4-foot surge and you're over 13 feet, solidly in that minor category. But again, the uncertainty that's shown here was the same as we talked about. It's due to the timing of that maximum surge. And so this is actually what happened here. First, I'll start on the right. This was the observed tide, 13.3 feet, and that was right in line with the forecast. Storm surge, a hair under 4 feet. So right in line with our forecast guidance. That was great to see. And on the left of the wave buoy, that's the Boston buoy outside of the harbor, seas reached up to about 21, 22 feet. And that unfortunately resulted in a lot more erosion along the ocean-exposed coast, especially when you get north of Boston to the North Shore, and in particular, Newburyport, the Plum Island area, was especially hard hit. But just an example of how we can use even the probabilistic data for our coastal flood forecast and help our emergency managers really prepare ahead of these storms. Now, something else new that we have, actually new within the past year, we've got some new tide gauge stations along much of the eastern Massachusetts coast. These were installed by a company called Huhanu. They're out of Hawaii, and they're working with the Woods Hole Group to install a number of low-cost tide gauges. So these are very, very helpful for us. Um, in addition, in Boston, since we already have tide gauges there, they've installed ones that measure flood depth in a couple of places. One is on Border Street near the waterfront, and you can see in this case, it observed just under a foot of inundation, which is considered minor. And then at Tenian Beach, just to the south a little bit as well, you can see just over a foot of inundation. So both solidly within that minor category, but we can observe these real time and kind of see what's going on as far as flood depth. So it's really a nice thing that this company has done. So that company also installed a gauge on Martha's Vineyard in Edgartown Harbor. If you're familiar with there, it's right near the Chappie Ferry dock, and we've been able to use that information now to provide daily forecasts for the vineyard at both Edgartown and Vineyard Haven. And in this case, the gauge and forecast worked out very, very well. Crested just over 4.5 feet or so. You can see, kind of solidly in between the minor and moderate. But when we take the wave action, this is the Nantucket Sound buoy, waves of about 8 feet, and put that into our table, you can see you end up solidly in that moderate category for both Edgartown and Vineyard Haven. And you can see these are actually the webcams showing both areas, Five Corners and Vineyard Haven on the top, with some fairly deep water, easily 1 to 2 feet. And on the bottom, this is right at the Chappie Ferry dock, easily about 2 feet of flooding there as well. So good to see that, these additional tide gauges really can help us out because they give us a lot more real-time data to work with. So we're continuing to work with Huhanu as well. Not just there, but I'll show you in a minute in Hyannis. For Nantucket, a very similar situation. A crest, solidly in what we call the minor category at about 5.6 feet. But again, we take those seas just outside the entrance, getting up 7-8 feet, and we're getting into minor to moderate impacts in Nantucket Harbor. And you can see clearly here, this is Easy Street, getting over a foot of water into that area. Many of the areas right around the harbor had about 1 to 2 feet of flooding. So good to see that this verifies as well. And we use that real-time data to also adjust these tables kind of as needed. So we've had several years of events going back and kind of refining these tables, but they tend to work very, very well. Now, the one thing that did limited us to more, worse impacts was the fact that winds were out of the east, and the orientation of Nantucket Harbor, it saved them a little bit. Typically, they have their worst flooding when winds are out of the northeast or even the north. So in this case, more of a due east wind really it didn't bring as much of an impact, which was a good thing. But still, somewhere in that minor to perhaps moderate threshold. Now, this is what I was talking about for Hyannis. We have a new gauge there as well, and we're working on providing forecast services and impacts, which should debut in the fall or definitely by next winter. This was interesting because the gauge actually peaked pretty high within Hyannis Harbor, right below moderate at about 6.2 feet. And we were expecting more of the way of impacts around the harbor and maybe Ocean Street in Hyannis, and really didn't see more significant flooding. And again, it goes back to the wind direction. Since winds are from the east, that tends to really prevent more significant flooding. Typically, Hyannis Harbor sees more flooding impacts when you have winds out of the south or southeast because the wind and the wave action can come right up from the Nantucket Sound. And you can see on this picture, Tori from our office was actually in Hyannis at a cooperative station that day. I had him drive out just to check it out. And this was after high tide, but you can see the debris line pretty clearly here in the park. Not getting further to the right of the picture on Ocean Street, but certainly enough, there was some decent inundation here in the minor category around high tide. So we're still working on Hyannis, but expecting to have these services rolling out in the fall, which is a good thing. So in summary, this late season nor'easter did prevent many potential impacts. From the winter weather standpoint, as we mentioned, the storm track of both the surface low and 850 millibars near the south coast really favored a warmer storm. The model forecast soundings showed the potential for sleet and snow, mainly in those higher elevations like in Worcester. And as we've mentioned a lot of times this winter, the use of these model snow depth change maps was much more appropriate than relying on our traditional 10-to-1 snow maps, since the temperatures were once again marginal, right around freezing. So that's always kind of what we call a best practice for these types of events. From the strong wind side, those ensemble anomalies of 4 to 5 standard deviations above normal climatology really suggested the potential for damaging winds several days in advance. And then kind of honing in, use of those model forecast soundings showed us the greatest potential for damaging winds along the coast, Boston, and around parts of the higher elevations, even the west side of those hills due to downsloping. So those were very, very useful there. For the rain, the flooding rain part, we saw that the global ensembles were in very good agreement on that potential for heavy rain several days in advance. And the higher resolution models, more accurately showed those bands of heavier rain, maybe not the exact location, but showed us the potential for that to occur. And really leading into this storm, having a very wet winter, a very wet early spring, resulted in continued high river flows, high soil moisture, so less for the rivers and the streams and the ground to absorb. And that led to another round of, fortunately, minor flooding this time for Rhode Island and eastern Massachusetts. And then the coastal flooding, as I just mentioned, the guidance from the Stevens Institute and even our probabilistic ETSS really accurately forecast a storm surge around 4 feet along the eastern Massachusetts coast. This resulted in essentially minor flooding, which we call less than a foot deep, to some moderate flooding in spots, particularly on Martha's Vineyard, which is flooding about 1 to 3 feet deep. And as always, it's the timing of the surge. That's always the biggest question mark. That's why we saw the uncertainty in those forecasts. But some subtle changes in the storm track also, as I mentioned, led to some uncertainty for the south coast, including Narragansett Bay. If we did have them more inland track, that would have resulted in southerly winds and a greater impact to the Narragansett Bay communities, less of an impact to the eastern Massachusetts coast. So with that, I'm going to pause here for a second, and I will go ahead and we're going to answer some questions. I'm sure there's quite a bunch. So let me go through here. And if you think of anything, go ahead and throw it in. Let me just take a quick look here. Actually have a forecast question, which I will get to in 1 minute, Gary. So hang on. Carla wants to know, what is the predominant wind direction in southern New England? Primarily, it depends, again, time of year. But, during our cooler months, it's primarily out of the west to northwest, to a lesser degree out of the north and northeast. That's most commonly associated with our coastal storms. In the summertime, depending on where you are, it's typically out of the south and southwest, especially when you get toward Cape Cod and the islands. It's really southwest, but areas like Hartford, Worcester, and even Boston are more out of the south. That's because we tend to have in the summer high pressure sitting offshore, and that pumps in kind of the warm and humid air into the region. So it depends on the time of year, but again, in the cooler months, west or northwest is predominant, and in the warmer months, it's more south or southwest. So a question from Tom, for Boston, below the inversion, what was the approximate depth in feet that produced snow? Really, for Boston, it was similar to that Providence sounding. So it was really right around freezing, maybe just a hair below it, but not deep enough to produce any snow. Typically you want to see, like for that Worcester sounding to really show snow, you'd want that warm layer to be much, less deep and cooler. You don't want to see temperatures of 6 Celsius. That's just far too warm. Typically only about maybe 1 to 3 degrees Celsius in that warm layer, which is, essentially mid 30s or upper 30s. And then for the colder layer, you want to actually be a lot more below freezing. So, probably getting about 1,500, 2,000 feet, 3,000 feet deep on that cold layer is going to help you. But it really depends on how warm and how cold those layers are, as opposed to really, the thickness of them. So I hope that kind of helps. And let me just get back to Gary here. So talking about Hartford County has a frost advisory still on for tonight. Thought only a frost or freeze warning was only issued or while the growing season has started. It's a little bit different now, Gary, and for everybody. So what we're trying to do is just kind of standardize things. The growing season actually changes from year to year. On a mild winter like we've had, things will start maybe a couple of weeks early. In a colder winter, colder spring, they're going to start a little bit late. So, and we're not experts in the growing season. That's kind of outside of what we do. So we kind of relate the starts and ends of our frost freeze program to the average date of the first frost and the last frost, if that makes sense. So we started April 20th with the South Coast areas and some of Connecticut as well. May 1st, we'll add the next tier kind of into the more of the interior. And then finally, May 15th, we'll add the far northern and western areas of Massachusetts. And likewise, we step them down that way in the fall. So we're kind of trying to get a consistent way of doing it with all of the offices in the Northeast, which can be challenging, but that's kind of how we do it. So that's why Hartford County's in the frost advisory for tonight. Not necessarily the growing season. We're just kind of correlated with kind of the new 30-year normals, which are 1991 to 2020 for that kind of first frost, first freeze, and the last frost and last freeze kind of throughout the year. So I hope that kind of makes sense. There was some information on our webpage a while back, but I think that might have dropped off at this point. So, and a quick question here from Stephen. Do different types of particulate matter determine the type of precipitation? No, it's really solely based upon temperature, although you can, what we've noticed is with particles closer to the ocean having more salt nuclei, you can get snow kind of at lower, warmer temperatures, I guess would be a fair shake. Better snow growth, like what we look at for getting those big fat, snowflakes that are like $half size. You normally want the temperature in that snow growth zone to be about -12 to -18 Celsius. But we've seen along the immediate coast to primarily Cape and Islands and even the Boston, it could be as low as -8 to -10 Celsius to get that good snow growth. So certainly warmer than what we would normally expect. So yeah, in a way it does. And what we really see is the differences between what we would call the fresh, water nuclei versus the salt water that's more common near the coast. So hope that answers your question. That we take that into account to some degree. But overall, other than that, we really don't at that point. So let me just pause here if we have any more questions. Not seeing any at the moment. Let's see. Oh, here we go. Bob threw it in. Okay. Didn't seem the media forecast honed in on coastal flooding. So what type of interaction is there between the NWS and private sector? So great question. So as you know, we provide briefings to emergency management. That's one of our main roles. And we really provide them either via email, which we did for this storm. For some of the higher end storms that we had this past winter, we will do actual video conference calls where we see them face to face. And of course, we answer questions if they give us a call or chat us at the office. The media, so we have a great partnership with all of our television meteorologists in all the markets, Boston, Providence, Hartford, Springfield, and even down into, say, New Haven in Connecticut. We share all of those briefings we give to emergency management with our TV meteorologists as kind of a courtesy. And that does a couple of things. First of all, it maintains a great relationship. They know what we're thinking, but it also helps us ensure a consistency in messaging. So it gives them a little more confidence that, maybe they're thinking something and we're thinking the same thing. Great. We can message things that way. The other private sector companies, we don't have a direct relationship. That's part of the public-private partnership agreement. We don't provide them specifically with information. That would be kind of the private weather sector companies, which have their own clients. But through like some of the state emergency management agencies, we do provide the information as well to some of the public utilities because that's in the interest of public safety. So that would be one example. Another example are hospitals. The emergency management for those, we also provide the information. Again, that goes to public safety. So if there's a direct, connection to some public safety, then we are able to include them in our information. But outside of that, no, we don't. So, we don't give forecasts to the private sector. They can, of course, see them. All of our information is public. And a lot of what we brief to emergency managers, we also share on social media. So I'm sure you've seen a lot of those slides as well. So the coastal flooding, I think, just in this case, Bob, wasn't the big attraction. It was overall minor with, a couple of areas of moderate. The big issue was really, two things, was the heavy consistency and wet consistency of the snow across the interior and the strong winds as well. So really the power outages were what we were messaging the hardest. And they, messaged that as well, which was appropriate. So my guess is that's just why the coastal flooding took a little bit of a back seat. And as we know, all these winter storms, there's so many things to consider. And this was certainly one of them. So, and Stephen's got a question. How many 90-plus degree days forecast for the summer? Oh, we will get to that when we get to the summer outlook. So stay tuned, and maybe we'll touch a little bit about that in May when we do our winter recap. But Stephen, we'll do that definitely in our summer outlook. That'll be coming in June. And we're going to ask you for all your forecasts as well. So start working on them. We'll be dealing with that probably in the early part of June. All right. So I'm going to stop the recording at this